12.11. Hey, on the bright side, we're not graphing. On the downside, we're doing proofs, and it's going to be great. All right, trig identities, which means we're getting closer to proofs and that line of thinking, which is great. It's going to be really good for you. But before we get started, we got to kind of go over a few things, a few definitions. So a trigonometric identity is an equation involving trigonometric functions that is true for all values for which every expression in the equation is defined. Basically, these are your trig identities, and they are always true, except for parts where it's not defined, which we would use something like this. Anyway, the identities help to evaluate functions, simplify expressions, prove identities, and solve equations. So let's get into it. So the main ones that we're going to start with, we've got the quotient identities, and this is just tangent equals sine over cosine, and cotangent equals cosine over sine. So one of the ways to think about this, and this is a very quick little proof, let's say we've got an angle here, and we've got A, B, C, right triangle. We can use trig functions. So we can say our tangent of theta would be equal to, by definition, opposite over adjacent, right? Okay, so now let's divide this one up into its more basic components. So I'm out of space, but whatever. So let's say we take sine of theta is going to be opposite over hypotenuse, and then divided by cosine of theta, which is adjacent over hypotenuse. So as I'm sure you remember, to deal with this complex fraction down here, we're going to multiply this by the top with the reciprocal. So it's going to be C over B, and then that gets that out of the way. So then when we do that, our C's cancel out, and you'll see that we have A over B, which is the same as tangent. So that's one way to think about these. There's also more complicated proofs that we may or may not get into, but that's at least one thing to think about as we're doing these. Okay, so tangent is sine over cosine, so cotangent is cosine over sine. That's just the reverse. I would memorize this one and just remember that cotangent is just the reciprocal. So same thing here with sine. So remember, each set of trig functions needs a co in it, right? So sine is linked up with cosecant. Sine is the same as 1 over cosecant. And you could say the same is true for the other. Cosecant is equal to 1 over sine. And these are all just definitions. Cosine is equal to 1 over secant, and then tangent is 1 over cotangent. And then, as I was mentioning, cosecant 1 over sine, secant 1 over cosine, and cotangent 1 over tangent. So that part's pretty easy. Again, these are things that you should probably put on your note card, memorize them, whatever. At some point, if you go into a math career, you will have them memorized. But so then what's kind of interesting is we can take the Pythagorean theorem and start to do some fun stuff with that. So here we've got cosine squared plus sine squared equals 1. So that's kind of a fun little thing that we'll use a lot. And then tangent squared plus 1 equals secant squared, and then cotangent plus 1 equals cosecant squared. So these are the things that are less obvious, in my opinion, but they are things that we're going to use, and I think we might end up proving them. Who knows? Okay, so how do we use these things to solve problems? Okay, so what we've got here, find the exact value of sine of theta if cosine of theta equals this thing. And then theta is in between pi over 2 and pi. So we're going to use our trig identities, and this part we're just kind of ignore for now. This just gives us This just gives us the fact that we're not going to deal with the entire graph. We're just going to deal with one section of it. So you'll see a lot of this, but this also tells us that we're in radians. So in case you ever have to use your calculator, whereas down here, this is where obviously in degrees. But anyway, I don't think that actually changes how we solve the problem. So we are looking for sine of theta. We are given cosine of theta, and that equals a thing. So let's come back up here. Which one of these has a sine and cosine? So we're looking for something that has both a sine and cosine. Our cosine is given. Our sine is solvable. We need something that that we only have one unknown. So that's why we're going to use this Pythagorean theorem. So, okay. Oh dear. So now we can write out the things that we know, the things that we don't. So we've got cosine squared of theta. We were given that that has a numerical value. So we can say -4/7 squared plus sine squared of theta. This is just typically how we write squared. We don't normally write squared on the outside here because then it kind of insinuates that it's with this theta. So this squared right here means the same as something like sine of theta. The whole thing is squared. Just an FYI. Okay, so we've got -4/7 squared plus sine squared of theta equals 1. We need to get sine of theta by itself. So we're going to move this over. So let's see here. 4 squared. So that's going to be 16/49. It is squared, so we lose the negative sign. But then we're going to subtract it to both sides. 16/49. So now we have sine squared of theta equals, we're going to make that one big number. So in my calculator, I'm doing 1 minus 16 divided by 49. Make sure you're entering it into your calculator correctly, and then it will give you a fractional answer. So that's what I got. Just skipping a little bit of the fraction math. So now we got to square root both sides, which is going to be, so sine of theta equals square root of 33. Does square root of 48 equal something nice? It does not. So then we have to, I did something wrong. Okay, so that shouldn't be 48, that should be 49. In which case, square root of 49 is 7. So sine of theta, the exact value is square root of 33/7. This is something that your calculator can't really do because your calculator doesn't do well with rational numbers just yet, or irrational numbers. So that's what we're here for. All right, next one, find the exact value of cosine of theta if cotangent of theta equals 2/5 and blah, 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 blah. Okay, so I don't really know where we're going just yet, but some information that we know, we are looking for cosine of theta, so I'm going to need to find something that has cosine of theta in it. And then we have cotangent, but don't forget that that is also the same as saying that we have a tangent of theta equals 5/2. So we have both of those. So then I'm going to look at our identities. I need something that has cosine and tangent. Okay, so one of our Pythagorean identities is tangent squared plus 1 equals secant. Well, cosine is the same as 1 over secant. So if we can solve for secant, then we can use that to find our cosine, right? So let's do that. Okay. So here we go. Our initial equation we're going to use, tangent squared of theta plus 1 equals secant squared of theta. Okay, so then we plug in what we know. We've got tangent squared, 5 over 2 squared plus 1 equals secant squared. 5 over 2 is 25 over 4 plus 1 equals secant squared. I guess I should include my thetas here. This is what I have a calculator for. So we've got, we'll go right up here. We're still in red. 29 over 4 equals secant squared of theta. We're going to have to square root both sides, and then we are going to get square root of 29 and then over 2. Square root of 4 is 2. So that's going to equal secant of theta. Okay, here's where it gets fun. So we just did all this math to figure this part out, but we're not actually to the right answer yet, because this gives us some very critical information. So trig functions can be positive or negative depending on where they fall on the graph. So what I did down here is I drew a quick coordinate plane, and let's talk about 180 to 270. So that is going to be, so if I think about, okay, starting here, 180, that's right there, and then 270 is right here. So we're just dealing in this quadrant right there. So if we use just any kind of triangle, that means that our line is coming out like this. So if we're talking about secant, or in this case cosine, cosine is going to be adjacent over hypotenuse. This value right here is negative. So this entire quadrant, all of cosines and secants are always going to be negative. So that's what this part means, and that means that our answer also has to be negative. So we are literally adding that negative sign in because of this part right there. So that's going to get challenging and get confusing, but that's okay. So then from here, though, we haven't used blue yet. From here, though, we are still looking for cosine of theta. We haven't found it. We only found secant. But we know that cosine is 1 over secant, or we can just flip things around. So let's flip things around. So now our cosine of theta is equal to negative 2 over square root of 29. We can't have square root of 29 on the bottom, so we are going to rationalize this. So that means that cosine of theta is equal to negative 2 square root of 29 over 29. And there it is. Let the fun begin. Okay, let's try simplifying some expressions. So simplifying just means combine it all into one trig function or turn it into a number. Typically, if you only see like thetas and stuff like that, it's probably going to be a trig function. But especially when you're dealing with like Pythagorean type stuff where it can equal 1 or something like that, then we might get a number 2. But let's try it out. So number 4, let's just write out the things that we know. So we've got sine. Sine theta is also equal to 1 over cosecant. But then we got secant, which I could also write as 1 over cosine of theta. Do you know anything that's sine over cosine? So definition of tangent is sine over cosine. So when we get sine over cosine, that by definition is also equal to tangent. So we have simplified that trig function. Okay, so number 6, that looks weird, but whatever. So we've got secant squared and tangent squared. So I'm immediately thinking, I see a squared, I'm thinking Pythagorean stuff. We've got a Pythagorean equation that has tangent in it. And if you remember, that is going to be tangent squared of theta plus 1 equals secant squared of theta. Okay, so we're really close. We got a tangent, we got a secant. So we're going to do a little bit of algebra. We are going to subtract our secant over. So we get tangent squared of theta minus, that's not what I want. We're going to do the other way. So since I want these two things reversed, I'm going to say we're going to subtract the tangent squared over. So we're subtracting the tangent of theta over. So that's 1. My handwriting is great. And then we're going to have secant squared minus tangent squared of theta. So now this matches this directly. So we can rewrite our equation now as 2 times 1, which just equals 2. So we simplified a trig function into 2. Okay, looking at number 8, again, we are trying to simplify everything. I have a feeling that tangent is what's going to help us. So I'm just going to rewrite everything, and I'm going to turn that tangent into sine of cosine. So remember definition, one of the definitions of tangent is sine over cosine. So I can say this is the same as sine theta cosine theta over sine theta over cosine theta. So now that's kind of convenient because our sines cancel out, and then this cosine is going to come up here. So now my final answer is just going to be cosine squared of theta does not equal anything. It's just, as simplified, it's cosine squared of theta. Okay, the moment we've all been waiting for. Proving identities. So if you've never done a proof before, here's your introduction. So the way that proofs work is proving an identity means to show that both sides of the equations are the same. Simplify one side using basic trig identities of the equation until it is the same as the other. Ideally, pick the side that is more complicated to work with. The reason we do that is if it's more complicated, all you have to do is simplify it so you get to the second side. There's basically 2 ways that you can do this though. You can either work with this side until it all equals sine, or you can do something where you simplify this side, and then they both equal the same thing. Generally, it's easier to just deal with one side and get it equal to the other. So same concept as simplifying, except this time instead of simplifying, we actually have a target in mind. And this realm of thinking is very important for a lot of different aspects of life and mathematics. So welcome to proofs. Okay, let's try one out. So we're looking at number 1, tangent and secant. I don't even know. So what I'm just going to immediately do is I'm going to start changing everything into sine and cosines. So by definition, remember, tangent is the same as sine theta over cosine of theta. And then secant is 1 over cosine of theta. Okay, so now I see that when I move this up here, my cosines are going to cancel out, which means that we only have sine of theta over 1, which is just sine theta, which equals my sine theta. Now, those of you that don't like to show your work, unfortunately, this is your answer. I don't need, oh yeah, it equals sine. No, this is the answer that I'm looking for. So you have to show your work because the answer is the work. Okay, looking at number 3, we've got cosecant on one side and we've got a bunch of garbage on the other side. So I'm just going to start simplifying this stuff until we get to something that is convenient. So remember, cosecant is 1 over sine. I'm just going to write that over here just so I don't forget. But we're going to predominantly work with this side and see what we can do with that. So number 1, let's rewrite cotangent and secant into sines and cosines. So cotangent, tangent is sine over cosine. So cotangent is cosine over sine. It's just how I have to remember it. Divided by, and then secant is 1 over cosine of theta. And that's just going to be plus sine of theta. So let's look at this thing. So we move this cosine up, and we're going to have, I'm running out of room. We're going to have cosine squared of theta over sine of theta plus sine of theta. Okay, so that I'm still not where I want to be, but I've got a cosine squared, so that immediately leads me to believe, like, can I do a Pythagorean trig identity thingy? So what if we actually wanted to add these? How would we add them? Well, we can't add them yet because we're missing a common denominator. So if we wanted a common denominator of, let's say, I don't know, sine. We wanted sine on bottom. We would have to multiply this by sine on top as well. So now we would have sine squared. So now we have cosine squared plus sine squared. So that we do have a trig function for. Cosine squared plus sine squared is equal to 1. So now, if we combine all these together, we have 1 over sine of theta, which by definition equals secant of theta. No, just kidding. Cosecant of theta, which is what we wanted. Now, when you're doing your work, please don't draw this line. I get it. I know that you've got there based on this work. I don't need you to draw that line. I'm doing it just so that you see that, yay, my two things are equal. Let's do one more and then I'll let you try some of these yourself in class. So we've got cosine squared equals a bunch of other stuff. So naturally, I'm going to start with this side and see if I can't just simplify that and see what happens. So the first thing I'm going to do is I'm going to rewrite this in terms of sines and cosines. I'm going to rewrite this just for fun, just to see what I'm looking at. So cosecant is 1 over sine, and that's going to be times cosine of theta. So I already see a tangent here, or a cotangent. So that's might be helpful later on. Okay, so we've got cosine over sine on the top. So down here, this tangent and cotangent, I have a feeling we might need to add those at some point. So I'm just going to rewrite this as tangent theta plus cotangent is 1 over tangent theta. So I don't know, let's make this top is going to be cotangent over, let's see here, where are we going to go from there? Okay, after thinking about it some more, I don't really like this cotangent because we're shooting for cosine, right? So let's get rid of the cotangent, and just change everything into sines and cosines and try to put everything together from that. So then on the bottom here, tangent of theta is sine over cosine. Cotangent or 1 over tangent is going to be plus cosine over sine. So let's add that bottom, because that's kind of where we're at. Let's just add this thing. So we need a common denominator. I guess I'll throw my thetas in there. We need a common denominator, which means that we are going to multiply this side by... so our common denominator is going to be sine times cosine. So we're going to multiply this side by cosine over cosine. We're going to multiply this side by sine over sine. And now that's going to turn this into sine squared plus cosine squared. So that's a thing that we have. That's an identity that we have. So let's do that. So now we are at, okay, cosine over sine. That's from right there. Over, so let's see here, sine squared plus cosine squared equaled 1. I had to look back up. Sine squared plus cosine squared does equal 1. So then we've got 1 over sine cosine. So now when this is our next step. So now when we move this up here, we're going to have cosine over sine times sine cosine and then all of thetas. I'm bad at writing thetas. So here we've got our sine and our sine cancel out. And then, looky, cosine times cosine is equal to cosine squared of theta. So there we go. We got it. And again, this is your answer. This is not your answer. I already have that here. So, welcome to Proofs.